So hi everyone, welcome back to my channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk about. So in this video we will learn what is a stack data structure, why do we need it, and what are the different 6 types or patterns of stack which we will learn. Then we can solve almost 90 to 95% of question in the interview or online assessment. So we will answer these 2 questions. What is a stack and why we need stack? So like array, stack is also a linear data structure. But remember, in array we have indexing, but in stack we do not have indexing. Then how we operate on that? For operation in the stack, we use functions like push, another function pop, and another peek. Push is used to add or append element inside the stack. Pop is for delete that element from the stack, and peek is just to check what is the top element in the stack. But remember, this push and pop you cannot do anywhere in the stack. You can only do at the top position. So this is how your stack data structure will look like. And suppose in array you have elements like 1, 2, 4, 5. So in stack, when you push element, first you will push 1 and you will bring 1 inside the stack. Now you will push 2 and you will append 2 element in the top of the stack. Next time you will add 4 and again you are adding this 4 element on the top of the stack. Similarly you will add 5 as well. And now suppose you have to pop the element. Then you cannot randomly go and say ki, hey, I want to pop 2 element. No, you cannot pop that. If you are popping only allowed for 5, once you pop the first element 5, top element, then you can pop 4 element, and then only you can achieve second element. So hence push and pop are only allowed for the top elements in the stack, and indexing is not there like we have in array. And now the second question, why we need stack when we have array? So in array, when we have elements like this, and suppose while iterating you iterated till 3, and once you reach 3 and now you want to go back and check what was the previous element like 2 or 1. So in array you need to iterate again. Basically you need to add another for loop to reverse back, and that will take O of n square time complexity. But in stack we do not need to reverse back and check back, because going forward we maintain the value in the stack, maximum value or minimum value, whatever is required for your condition. So remember, whenever you need to backtrack in the array, you will use stack data structure, or you need to traverse from right to left, like how we did here. When we reached 3, we wanted to go back, means right to left we want to traverse. Then we will use stack data structure. Or you can say when you want to minimize your time complexity from O of n square to O of n, you will use a stack data structure. If space complexity is also allowed, because using stack will take O of n space complexity as well. So this was all about what is a stack and why do we need it. Now we will see different patterns of stack one by one. First pattern is monotonic stack. Monotonic stack means if suppose you have elements like 2, 4, 3, 8, 1. So monotonic stack means in stack you know that you will push the elements always at the top of the stack. So you will push 2, 4, 3, 8, 1. But monotonic says ki when you will be maintaining these elements inside the stack, that will be in either in ascending order or in descending order. Means the stack can have values like 2, then 1 only. And problems like next greater element, next smaller element, daily temperature, etc. are from this category. And almost 25 to 30% of stack questions belongs to this. If you know how to maintain the monotonic stack, you can solve most of the interview asked questions. And about the thing how to maintain this monotonic stack in coding, that we will see when we will be learning or solving questions around this pattern in our playlist. Now the second important pattern is expression evaluation. So remember, whenever question includes operators like plus, minus, multiplication, division in the input array and you need to evaluate the expression, you can use stack data structure there. Why? Let's see. Suppose an example 2 plus 3 multiplied by 5 and minus 4. This is your input string. And now you have been asked to evaluate this expression. So if you will evaluate with the logic of BODMAS rule, you can only do multiplication, division at first, and at the end you will do addition and subtraction, correct? So with this logic, if you will evaluate this, your final answer will be 2 plus 3 into 5, 15 minus 4, and at the end it will be 17 minus 4 means 13 as an answer. answer. So what you did? So basically you evaluated 3 and 5 first, and then you went back and then added this 2 and then minus 4. So you are actually backtracking towards left side. So this, you know that if you will backtrack with the array, means 2 for loops, that will cost you O of n square time complexity, and for that we use stack data structure there. So let's see how we will solve with the stack data structure. We need to keep 3 pointers. Why 3 pointers? Suppose we are at I is equal to 0 and we have a number 2. But with 2, what you want to do? You cannot do anything. So you will move forward and you will move your I to plus operator. Now you have a number 2 previously encountered. Suppose that you will save in stack 2. And you have plus operator. But for operation, you need one more operand, correct? And again for that, you need to move forward. So you will move to 3 here, and now the time you encountered this 3, you can say okay, first operand you have in stack, so this plus you will store in the OP operator. But now can you say ki you are allowed to add this 2 plus 3? No, you cannot, because you have to follow the BODMAS rule. First you have to do the multiplication and division, and at the end you will do plus and minus operator. Because if you will do plus operator here first, so as per that 2 plus 3 will give you 5, then multiplied by 5 will give you 25, and then minus 4 will give you 21 as an answer. But you just saw ki 13 was the expected answer for this case if it follows the BODMAS rule. So hence whenever your operator will be plus, you just need to push back this 3 also in the stack with that plus sign. So what you will do, if your operator is plus, you will simply push that 3 also with the plus sign. Next time you will move your I to multiplication. Again you have this operator. Next time you will move this I at 5 and this operator will become multiplication, correct? So this time when you have then operator multiplication and the numbers you have in this, so this multiplication will be done with this 3 or with 2. Of course this 3, because that is the nearest number to it, and that is stored in the stack top value. So we will simply pop this 3 out, then we will do this operator multiply with this current element which is pointed by I here, and this will result 15, and now this 15 we will store back in the stack. So can I say I will simply remove this 3 from here and I will add 15 here. Correct? Now my I will point to minus, and this OP will also shift to minus. Now again will I move to 4. Remember, I will be continuously moving until it is not touching any digit value. So now you can say the I is pointing to 4 and the operator you had minus, and you know to follow the BODMAS rule you will give equal value to plus and minus. So with this negative sign you will insert the 4 element in the stack, and at the end you just need to give the summation of the all elements of the stack. So summation of all elements will be minus 4 plus 15 and plus 2. So total it is 13, and as per the BODMAS rule 13 is the correct answer here. So all the question like basic calculator 1, basic calculator 2 you will be doing with this pattern. Whenever question includes any operator and you need to evaluate, you can think of this pattern. Now the next very important pattern is stack undo operation, and this is very simple. So whenever the question says ki while encountering some unique character you have to undo, basically delete the previous element, you can think of stack there. How? Suppose you have been given a string like A, B, 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 A, C, C, and it says whenever you encounter another B, you can delete the previous B. So suppose you do not know about the stack data structure. So with brute force approach, how you will solve? You will start with I at 0th index value, and you will say ki as of now you do not have anything towards the back side, so you won't run any for loop there. So next time you will move your I to first index, and you will start your J loop from I minus 1 till left side, and in this case you can only move J for one time, and you will say if your I and J matches then delete, but here it does not match. So next time again your I will move to second index, and again you will do the same thing. You will start your J pointer from J is equal to I minus 1, and since this character does not match, so you will not go leftward, because it is not saying ki with this B you can delete this B also. No. you can only delete another B if you have found B just at the consecutive place. So in this case also you will move your I pointer to I is equal to third index. Now you will start your J pointer from I minus 1 and you will say yes, J and I character matches, so you can delete this. So if you will delete this, you know that if it is array or string, it will, all the characters after or forward to it will rearrange itself, and that will take O of n time complexity again. So in total O of n square time complexity, and which is not optimal approach. So let's see with stack data structure how can we solve this problem very easily and in just O of n time complexity. We will use a stack data structure. First character we encountered, this we will save in stack. Next time we encountered A, and we will check ki if this encountered A and the stack top element matches, then we will pop this stack top element, because popping, can you say ki yes you have deleted? Yes, you can say. Why I am saying? Because at the end I will return this stack as an answer. So basically deletion means popping, and because you are popping the top element, so there is no need to worry about rearrangement of the upcoming future elements, because at the top you have only one element, so you will simply delete it without any rearrangement cost. So in this case A and B does not match, so you will simply put A back again in the stack, and this pointer you will move to next I is equal to 2 index. Now here again you will check if your this B and A matches. No, it does not match. Again you will repeat the same process. You will insert B and this pointer you will move to next B. Now this time you can say ki the current index I, which is pointing to the B, and this B as a stack top element, you can delete this B. So what you will do, you will simply do stack dot pop, and that's it. Will you stop here? No, you will keep on continuously checking until the condition fails. So here A does not match B, so hence condition fails, so you will stop here. Next time again you found B, so you will move this B, but wait, because of this B, the previous B which was there in the stack you have deleted. So are you going to push back this B again? No, you will not, because the question says when you encounter the duplicate B, your task is to remove both B. So the previous B, so you have removed in the stack, but this B removal means do not push in the stack itself. So in this case you can say both are deleted. Next time this pointer will point to next B, and now you will see ki yes, this B does not matches A, so hence this B again will be pushed back in the stack. Now next time you will encounter A, and again this A will not match with B, so this A also you will push back in stack. Next time you will move to C, C and A does not match, so you will again push this inside the stack. Next time this C and this C and the top C matches, so you will simply delete this stack top value and you will not push this C at the end. So in total this stack has value B, A, B, A, read from the starting, and this is your answer. And if you will see like this also, if you want to delete, so this B will cancel out this B and this C will cancel out this C. B, A will not be cancelled out, and this is called stack undo operation. So undo operation is nothing but keep removing the adjacent elements as per the question. So this pattern I found it very easy, and if you want to practice more questions from this pattern, I have already added in my sheet which you already know about. The link is already in description, or at the end of the video I'll show you how it looks like. Now let's move on to the another pattern called parenthesis pattern. Parenthesis pattern means, suppose you will be given some pattern and you have to check if that matches or not. So basically whenever you will be asked to match the parenthesis, you can think of stack data structure there. Why? Because whenever you will encounter any open bracket, you won't do anything. Basically parenthesis matching or checking begins when you found both open and closing bracket. Correct? So in that case, first you will encounter this closing bracket and then you will go back towards left side. And whenever you have to go back towards left side or backtrack, you know what you have to use. Yes, that is stack data structure. So the logic simply says, whenever you are encountering any open bracket, just store it in the stack. So you will store this. Next time you will move this pointer to next, and again open bracket you will store, and now the time you found a closing bracket, your time starts now. You have to check this closing bracket matching with the stack top element only, because those should be consecutively present. If that is true, you will simply pop this out and you will go to the next bracket, which is again small closing bracket. Again you will match with the stack top element, and this matches. So again you will pop this out. Next time you will encounter a opening bracket, and you know, in opening bracket you will simply push in the stack. You don't need to match anything. Next time you will find the closing bracket and stack top element is also curly but open. Hence these are matching. You will simply pop this out. Next time you will move to closing bracket of square, and in the stack you have open bracket for stack. Again you will simply pop it out. So at the end you saw, if you would have not used a stack, so from this point to this point, again you have to run a for j loop from I minus 1 till I is equal to 0. That will take O of n square time complexity. So remember, whenever you have to match any parenthesis or count number of parentheses to make valid problems, you have to use stack data structure there. So the rule is very simple, and I am saying whenever you are encountering any parenthesis based question, you can go for stack data structure. But remember, if you are allowed to take extra space complexity, because stack takes O of n space complexity. Now the next pattern is stack based design. I won't say it is easy. Mostly beginners found it difficult, but I won't say it is hard also. Stack based design means you have to use a stack data structure and you will be asked to design another data structures like queue. You know how queue behaves? Like in stack, last in first out. Correct? Last in first out means when you pushed 1, 2, 3, 4, and when you want to pop, so means you are actually popping the last inserted element only. Correct? But in queue data structure, queue says if you are pushing 1, 2, 3, 4, so 1 you have inserted first, so if you are popping, your 1 should come out first as well. So with the help of stack data structure, you have to design queue data structure, and for that you need to use two stack, one for input or push operation for queue and another stack for pop operation for queue, and that you can check out from my playlist. So the problems like min stack, max stack, design queue using stacks, all these questions will fall under this category where you will be using two stack data structure to design a new data structure. And trust me, you just have to practice 3 to 4 problems from this pattern and you will be done with this. And last but not the least, recursive stack. So basically you will be using stack data structure only, but you will be asked to do some operation via recursively. Means suppose you will be given a stack data structure and you have an elements 1, 2, 3, 4, and you will be asked using the recursive function you need to reverse this stack such that the stack will look like 4, 3, 2 and 1, or else you will be asked you have this stack, first stack 1, 2, 3, 4, and you have to go and delete that last element, and you know in the stack you are only able to delete the top element. So how can you go deeper inside and delete 1? Yes, I know what you are thinking. You are thinking you will simply pop this 4 and store in some variable or extra data structure, then you will pop 3 and store, then 2 and store, and then this 1 you will pop and you will not store. And all these 2, 3, 4 you will again push back in the same stack. But remember, recursive function do not allow you to use any extra space complexity, means extra data structure is not allowed. You have to traverse till the end and you have to insert a new element there, or you have to reverse, or you have to go till mid and delete something, etc. Means recursively you have to call the function and you have to do some manipulation in the stack. Extra space not allowed. So with the recursive function you can solve this pattern. All the important questions from these pattern you can check out from my DSA sheet, which I have curated for you all pattern wise, so that all these patterns we will be discussing in this video, and for practice you can check out that sheet. The link is already in description. So this was all about the whole video. Here we have discussed what is stack data structure and why we actually use. Is there any indexing in the stack or not? Then we learned about 6 different patterns. First we learned about monotonic stack. It is similar to stack only, but the elements will be sorted in ascending or descending order. Second, we discussed about expression evaluation, where we saw whenever question includes operators and it asks to evaluate, we will use stack data structure because we need to backtrack there, and backtracking means we will use stack there. Then third, we learned about stack undo operation, where whenever we encountered a duplicate problem we have to go back and then delete that duplicate duplicate element. Fourth pattern was about parenthesis. Whenever we have to count parenthesis or check or match parenthesis, we use that data structure called stack. Next, we learned about how we are using stack data structure to design a new data structure called queue, min stack, max stack, etc. but using 2 stack instead of 1. Last was recursive stack, where we have to manipulate the stack without using any extra space or any extra data structure. So trust me, if you are going to remember these 6 patterns, you are not going to miss any single question in the interview. So I hope this video was helpful. If it was, don't forget to share with your friends and do subscribe my channel if you want to learn everything pattern wise and more conceptual. I am here to simplify data structure in pattern wise and more curated form so that you don't need to memorize the code. Instead, you just need to remember the patterns there. And the last thing, if you have understood every pattern, then you need to solve questions around these patterns. At least solve 3 to 4 questions from all these patterns and you are done with the stack data structure. That questions you can check out from the DSA sheet which I have curated for you all, and as you solve the question, just tick mark so that you can have idea how many sheet you have covered till now, and the link is in description, you can check it out. So that's it for the video. Let's meet in another video. Till then, keep learning, take care of yourself and your family.